Hi folks, welcome to this video, which is about factoring by area. So let's get started. What do I mean when I say factoring by area? Well, let's go back to when we first learned how to FOIL or distribute, and let's start with this example. Let's say we have f of x equals 2x minus 1 times x plus 5. And if you had a teacher who said, I want you to FOIL this out, or I want you to multiply this out, then you could have used FOIL, where you do the first and outer and inner and last, and then combine your terms, okay? And that would have given you 2x squared plus 10x minus 1x minus 5, or after you combine your like terms, we would get 2x squared plus 9x minus 5. Now, there's actually another way that we can kind of think about factoring, and that is what I'm calling factoring by area, okay? So sometimes when we're learning how to FOIL, we tend to make a lot of sign mistakes. And so one of the ways that I found around that is that we can use the idea of area, of rectangles, okay? And so what we typically do in this model is we take one of the factors and we put it at the top. And then we take the other factor and we put that down the side. So x and then plus 5. Okay, so this x plus 5 is the same as the x plus 5 in the equation. And this 2x minus 1 is the same as the 2x minus 1. And so now all we're going to do is multiply the sides of each rectangle, and there are 4 rectangles in here, to find the area of the total. And so in this top left-hand box, we have x here times 2x, and that's going to give us 2x squared. Now I'm going to do the same thing for the top right-hand box, and we have this side is x, and this side is -1, so the area of this top right box is -x. Now I know that area can't be negative, but we're using it as a model rather than something that we could actually apply in real life, okay? So now let's move to the bottom left-hand box. So 5 times 2x will give me 10x, and it's a positive 10x. And then 5 times -1 will give me -5. And what I have is all the same terms I got using FOIL, just in a different form, okay? And so if I combine my like terms, I'll get back to 2x squared plus 9x minus 5. Now, just to show you that the factors could be switched, we're going to do this again, but instead of having the 2x minus 1 on the top, I'm going to put the 2x and then the minus 1 along the side. And I'm going to do the same thing where I put the x plus 5 on the top. Okay? So some people like to set it up differently, which is why I just want to show you that it could work either way, okay? Now, if we find the area of each of these 4 rectangles, we'll get 2x squared. The top right-hand box will be plus 10x. The bottom left-hand box will be minus x. And the bottom right-hand box will be -5. And once again, if we simplify everything, combine our like terms, we'll get to our final answer, 2x squared plus 9x minus 5, okay? So what we're going to do in this lesson is we're actually going to use this idea of area, and instead of trying to find the inside of the rectangle, we're actually going to be trying to find the outside of the rectangle. So we're going to be given something like this, and we're going to try and find the pink and the yellow factor, okay? So since we know where 2x squared plus 9x minus 5 comes from, let's use this example to go backwards. Okay, so let's say we had f of x. F of x equals 2x squared plus 9x minus 5. And someone said, hey, I want you to factor this. And instead of panicking, we're going to try this method of factoring using area. Okay, so let's see where we're going to start with this. So what we're going to do is when we factor using this method, our goal is to figure out what the outside parts are, the yellow and the pink. So we'd have one factor and then we'd have another factor. And so the first thing we're going to do is we're going to find some numbers. I want you to find a pair of numbers that multiply to make -10 and add or subtract to make +9. Okay? Now, we'll talk more about where those numbers came from, but right now I want us to think about a pair of numbers that multiply to make -10 and add or subtract to make +9. And so let's list out some factors of 10. So we've got 1 and 10, we've got 2 and 5. Now, I can see immediately that 1 and 10 multiply to make 10, but I could figure out how to subtract them to make 9. And so, in fact, what we want to say is that +10 and -1, that's the pair of numbers that will multiply to make -10 and add or subtract to make +9. Okay, now once we've got those numbers, we're going to use our area model. Okay, so we're going to draw a box and we're going to divide it into 4 rectangles. And we're going to go back to our numbers that we just found. Okay, so I'm going to have a +10 in this box and a -1 in this box. Or if you wanted to do it the other way, you could have a -1 in this box and a +10 in this box, and that would be fine. Okay? But let's go back up for a moment to the previous example that we did. When we were looking at the boxes in the top right and the bottom left, this box and this box, okay, the 10x and the -x, or the -x and the +10x. Those boxes have an x with the number. So it's not just a number, but it's the number and the x, okay? So we want to kind of follow the same idea and have -1x, 10x, 10x, and -1x. And here's why we want those. If we go back to when we used FOIL, we have 10x minus 1x, and we split those up essentially to be in the top right and the bottom left corners of our box, okay? So similarly down here, this is the first thing that we put into the box. Remember, we're trying to find the yellow and the pink, not the inside. Now, what do we put in the box next? Well, we actually go back to our original problem. Whatever our ax squared is, that goes in the top left box. So 2x squared goes there, or 2x squared could go here. And those are the orange matches with the first term in my original problem. Now, I'm going to ask us to wait until the very end to fill in that last box, okay? I know some of you are probably thinking, oh, I bet that's -5. Let me just write it in there. But we don't want to write it in there yet. We want to actually use this as a built-in check system to make sure that we are correct. So what we're going to do now is we're going to try and find two terms that multiply to give us this 2x squared. Well, I could have 2x times x. That's going to make 2x squared. Now I could put the 2x here and the x here, or I could flip-flop them, okay? So we need to be really careful about what we put where. So let's pretend like we put the 2x on the top and the x on the side. Well, now we need to find a whole number in that question mark where 2x times the question mark gives me -1x. So think about that for a moment. We need to find a whole number that 2x times this whole number gives you -1x. Well, that's not possible. There's no whole number that does that. So if you run into that situation, it's an easy fix. All right, you erase a little bit, you switch your 2x and your x. So let's put the 2x on the side and the x on the top, okay? And now let's try this again. 2x times what whole number gives me -1x? And I think it's pretty clear that that number is -1, okay? Now 2x times what whole number gives me 10x? Well, 2x times 5 is going to give me 10x. Okay, so I found the outsides of my box, but to check that I'm correct, we want to multiply this side, which is -1, times this side, which is 5. That gives us -5. Now -5, if I go back a little bit, -5 is the last number in my original question. That means that you factored it correctly, okay? And so as you can see, we have one factor here, x and 5, so that's an x plus 5, and this one is 2x minus 1. And so we could write our answer like 2x minus 1 times x plus 5, okay? Now, let's show the other way. Let's say you didn't put your 10 and the -1 in the same places as I did in the first one, but yours looks like the second one. Well, turns out it's not really going to matter. We just have to be really careful where we put our 2 and our x, our 2x and our x. So we want to make sure the 2 lines up with this 10, so 2x and x. Because if this side is 2x, this side must be plus 5 to give that box an area of 10x. And if this box has an area of -1, and this is x, then this side must be -1. And I'm going to check by doing 5 times -1, that gives me -5. And I'm really happy to see this -5 because that's the same as the last term in my original. And so we could write our answer as 2x minus 1 times x plus 5. Or we could flip-flop it around and we could write it as x plus 5 times 2x minus 1, okay? So the order there doesn't necessarily matter. If it's pink and then yellow or yellow and then pink, the order doesn't necessarily matter. But what matters is that the pink is the same as the other pink and the yellow is the same as the other yellow, okay? So let's zoom out for a moment so you can see the whole page on one screen right now. But basically what we mean by factoring by area is using a visual to help us unpack or go backwards and figure out, if we know the area, how long are the sides, okay? So hopefully that was a message that came through to you in the exploration on Desmos, if you chose to do that one. But now we're going to move on to practice 4 questions, okay? Let me zoom back out and let's practice, okay? So let's take a look at example number 1. Example number 1 says f of x equals 2x squared plus 3x minus 20. And so when we see this, we want to factor it into something times something else. And so what I like to do is think about pairs of numbers first and then put together the box, okay? So sort of a shortcut way, instead of having to write out in a long sentence every time, find a pair of numbers that multiply to make this and add or subtract to make that other number, I use an X, okay? And so with this X on the top, I put the B value, and on the bottom, I put the A times C value. So let's try that out. In this case, the B value is 3, because that's the coefficient of x. And in fact, it's a positive 3. A times C is going to be 2 times negative 20, or negative 40. Okay? So now I need to find a pair of numbers that multiply to make A times C and add or subtract to make 3. All right, let's list out some factors of 40. So 1 times 40, 2 times 20. Let's see, 3 doesn't go in, 4 times 10, 5 times 8. And I think those are all the pairs. Well, of these pairs, which ones can I make into 3 by adding or subtracting? And I think you'll agree that 5 and 8 can be subtracted to make a positive 3. So I'm going to put these numbers here, 5 and 8. But if I leave them as positive 5 and positive 8, I'm going to end up with 14, and that's not the number I'm looking for. Or 13, sorry. I'm not looking for 13, I'm looking for 3. So one of them needs to be negative. But we have to choose carefully. We can't just put the sign on one of them and hope for the best. That's how we get factoring wrong. Let's think about this. If I have 5 and minus 8, that's going to give me negative 3, not positive 3. So that's not right. Okay, well, how about minus 5 and positive 8? Yeah, that makes a positive 3. And also when I multiply them, they make negative 40. Okay, so these two numbers that we found right here, I'm going to color them green, because if we go back and look, those numbers that we chose, the 1 and the 10, became that 10x and that negative 1x, or this negative 1x and this 10x. Okay, these are the coefficients for my linear term. So knowing that, now let's create our box to help us visualize the area. So remember, I can put the 8x and the 5x either in the top right and the bottom left, or the other way around, and it doesn't matter. For this question, I'm going to put a plus 8x up here and a minus 5x down here. And again, those numbers came from the green ones above. Okay, what did we do next? Well, next we went back to the original problem, and we grabbed the first term there, and we wrote it in this top left-hand box, 2x squared. Okay, now we want to save that last box so that we can check. All right, we want to save this box to check our answer. That's kind of what I really like about this technique, factoring by area, is that there's a built-in check to tell you whether you did the problem right or wrong. Okay. All right, so now we got to figure out the outsides. This part and this part together have to multiply to make 2x squared. But I look ahead and I notice there's an x that has an 8 in front of it in the right. So that's really where I want to line up my 2, because 2 times a positive 4 will give me 8. So 2x times a positive 4 will give me 8x. Well, if this side is 2x, that means the top side is just x. And x times what whole number gives me negative 5x? And that is going to be negative 5. And now let's double check. Negative 5 times a positive 4. Ooh, it does give us a negative 20. All right, so this negative 20 is the same as this negative 20. So give yourself a high five or a pat on the back. You factored it correctly, okay? And so it doesn't matter which one goes first, but one of them we can say is the yellow factor. All right, I'm going to write that in here. And then the other side is the other factor. And so in order to write our final answer, we can say that 2x squared plus 3x minus 20 factors into x plus 4 times 2x minus 5. Okay. All right, let's try example number 2. All right. So we've got f of x equals 4x squared plus 7x plus 3. Okay, so we're going to start off by finding our b value and our a times c value. All right, b is going to be 7. And a times c will be 12. 4 times 3 gives me 12. Okay. So let's find the factors of 12, because we want to find numbers that multiply to make the bottom and add or subtract to make the top. All right, so to multiply to make 12, I could do 1 and 12, or 2 and 6, or 3 and 4. Which one of those pairs makes 7? 3 and 4. And this one, in this case, since they're both positive numbers, positive 12 and positive 7, then our factors are just going to be 3 and 4, both positive. Now I want to highlight these in that green, because remember, this 3 is really 3x and the 4 is really 4x. Oops. All right, let's set up our area box. Okay, so plus 3x plus 4x. And I could have written it the other way around also, 4x up here and 3x down here. Either way is fine, okay? Now we're gonna go back to our original equation and look at the leading term. That leading term goes in this box, 4x squared. Okay, now I could make 4x squared by doing 2x and 2x, but if I had a 2x here, I would not get a whole number there to multiply to make 3, okay? So that tells me that I should not do 2x and 2x, but maybe what would be better in this case is 4x and x. 4x times a 1 gives me the 4x in the green, and then x times 3 gives me the 3x in the green. Remember, I'm saving this box to check my answer, so 1 times 3 is 3. And 3 is my last term. So I factored correctly. And we can write our final answer as 4x plus 3 times x plus 1. And we could call the 4x plus 3 one of the factors, and the x plus 1 is the other factor. Okay? All right, let's go ahead and try example 3. Okay, so with example 3, now I think this kind of factoring tends to be easier for folks because our a value is actually 1, but I want to show you that this technique actually works for when a is 1 as well. We're going to start off the same way. We're going to have our b at the top and our a times c on the bottom. So b is 14. A times c is 1 times 40, or 40. All right, let's find some numbers that multiply to make 40, but also add or subtract to make 14. All right, 1 and 40 make 40. Well, 2 and 20 make 40. Let's see, 3 doesn't go in. 4 times 10 make 40, sorry. 5 times 8 make 40. And of all of these pairs, 4 and 10 are going to make 40, but also add or subtract to make 14. So let's get a positive 4 in here and a positive 10. These ones are our green numbers because the 4 really stands for a 4x and the 10 really stands for a 10x. Now, let's set up our grid. Let's put the 10x up here. Let's put the 4x down here. Remember, those are just from the step before. We're going to take our leading term and put that in this first box. Okay. And now part of the reason these questions are so easy to some folks is there's only one way of making x, and x. That's it. X and x make x squared. Now, the rest of it is actually pretty simple too. X times 10 will give me that 10x. And x times what gives me 4x? Well, it's going to be plus 4. And of course, we saved our last box to multiply. So we could check, is the number in this box the same as the number at the end? And it is, so we have factored correctly. And we can say that x squared plus 14x plus 40 is the same as x plus 10 times x plus 4. Okay. Remember, you could also write that as x plus 4 times x plus 10. All right, so these cases are actually a lot easier than the other ones. I really encourage you to feel pretty solid on these cases, but also in ones like example 1, example 2, and the one we're about to do right now, example 4, okay? All right, so let's try example 4. Set up our x. We need a b value on the top. We need a times c on the bottom. So b is not just 4, but it's negative 4. So we want to make sure we take the sign with it as well. And a times c is going to be 6 times 16, which is going to give us 96. Okay. Now, if these numbers are looking pretty big and you're like, I don't really want to find all the factors of 96, let's actually go back and see if we can't make this a little bit easier for ourselves, okay? So one of the things that I like to do as I'm going through a factoring problem is I like to see, is there a greatest common factor that I can pull out of the whole equation. And when I look, I notice that every single term can be divided by 2. So I'm going to factor out a 2, and then I'll be left with 3x squared minus 2x minus 8. Now these numbers look a lot nicer. So what I'm going to do is I'm going to redo step 1. I'm going to use -2 as my b, and 3 times -8, or -24, as my a times c. Now, some of you might be better at computing with larger numbers than I am, but I like to kind of keep it simple if I can, okay? And so I'll notice, whoops, that should be a -96. I think it's easier for me to find factors of 24 than it is of 96, okay? So I know 24 could be 1 and 24, 2 and 12, 3 and 8, 4 and 6. And of those 4 pairs, only 1 pair can I add or subtract to make a -2. Now, if I put a 4 here and a 6 here and call it a day, I've not done my job, okay? Because 4 times 6 don't multiply to make -24. And they certainly don't add to make -2. So what can we change to make this pair multiply to -24 but add to make -2? Well, if we make the 6 negative, 4 times -6 is -24, and 4 plus -6 is -2. Okay, so we do have to be patient. There's no magical cure for playing around with the numbers. You just kind of have to do it, okay? But once we've got these 2 numbers, our 4 and our -6, we can move on to step 2. All right, I'm going to put a 4x here, a -6x down here, because those are my linear terms. I'm going to go back to my original equation and grab that leading term, 3x squared. Okay, now I went back to the 3x squared because that's what I used to create this, okay? If I worked it through with the -4 and the -96, I would have to use 6x squared to start with. Okay, so let's think of ways that we can multiply to make 3x squared. Well, we could do 3x and x. Now, if I put a 3x here and an x here, it would be okay this way, like a -6, but 3x times no whole number makes 4x. So that's okay, we just backtrack a little bit. So we get rid of that, we get rid of that, and we just switch our 3x and our x. Okay, now we try again. 3x times -2 gives me -6x, and 4 times positive 4 times x gives me 4x. Okay, so if it doesn't work the first time you try it, try flip-flopping the numbers and seeing if that helps. All right, now when we multiply this last box together, we should get a -8. So let's hope this is -8. Let's see, -2 times +4. Whew. All right, that's -8. That means I factored correctly. And so when we want to write our answer, okay, we have to remember we already factored out a 2. So this 2 has to be part of our answer. And then we're going to take 3x plus 4 and then x minus 2. And we could say this is 3x plus 4, that's one factor. And this x minus 2 is another factor, okay? And then we actually had a third factor from the beginning, and it's okay for one of those factors to be a number. That's okay, all right? Okay, so thanks for watching this video. I hope that it was helpful. A little bit more more about factoring. Like I said, it's going to be a skill that we use in this class, in the next class, in the class in the spring, in Calc 2, in pretty much any math class you take, you're gonna need to know how to factor, okay? So if you want to get those extra credit points, you can go ahead and take a look at these 3 practice problems, write them out, use the same methods I showed here in this video, solve them, get them back to me. You're going to email me yours to get up to 2 points of extra credit on exam 2. Okay? All right, folks, let me know if you have any questions. See you later.